This is Dr. Nick from the ECG Academy with the second of many Chalk Talks that will help you become an ECG expert. It's easy. Just log on to ecgacademy.com for basic instructional videos, and these Chalk Talks will help you get used to reading the more complicated tracings. Anyway, this is number 2, and it's not that complicated, but number 3 will pick up where this left off, and I promise you it'll be more challenging. This one, if you look at the forest, you're looking at an irregular heartbeat here. And the question is it irregularly irregular, or is there a pattern of regular irregularity? And you should be able to notice right away that there is a group of 2 QRS complexes, and then there's a pause, another group of 2 and a pause, and then finally a group of 2. So there's group beating going on, and it makes you think that there may be some kind of conduction disturbance. Well, let's look more closely. Remember, these 3 lines are going simultaneously, so you can look at 3 different leads. And if you look at the first beat, it looks fairly normal with an upright P wave, a QRS complex, and a pretty smooth-looking T wave. The QRS is a little abnormal. There is a strange-looking wide S wave here. If you measure the entire QRS complex, it's only about 110 milliseconds. So this wide S wave and this RSR prime in V1 suggests that there is an incomplete right bundle branch block going on, but that's something for a 12 lead to confirm. Anyway, the PR interval of this beat is about 200 milliseconds. It's at the upper limit of normal, right about 1 big box. The next beat comes along, and if we measure the rate, let's count off 300, 150, 100, 75, 60. So it's a little bit faster than 60, maybe 68 beats per minute. The PR interval still looks to be about 200 milliseconds, and the QRS looks the same. Well, if we measure off another 68 beats per minute, we find that there does seem to be a P wave that does appear to land on time, but there's no QRS associated with it. So it appears that AV block had occurred because this P wave never got down to the ventricles, and somewhere in the AV conduction system the signal never got through. Well, let's keep on going. Following this pause, there is another PR interval that's 0.2 or so, another one that's fairly constant, and then this P wave blocks. And so you have AV block with a fixed PR interval. Now, if we look at all different AV blocks, we remember that you have first, second, and third degree, where first degree, all the P's conduct. It's just your PR interval is a little bit long. With third degree AV block, none of the P waves conduct. Well, clearly some of them conduct in this tracing, so we have second degree AV block, and you should already know that with a fixed PR interval and no increase, that should be type 2 second degree AV block. Well, there are a couple of things you have to make sure. First of all, you have to make sure that this P wave is in fact on time and is not simply a non-conducted or blocked APC. So if you grab your calipers and move it on over to the P waves, you look at the P to P interval, and sure enough, this P does occur on time. In fact, all the P waves appear to be regular, and that is one of the requirements to say that second degree AV block is present, and that is the P to P interval should be regular. The other characteristic of type 2 second degree AV block is that the pause that results from the blocked P wave should be exactly 2 times the previous R to R interval. So if we take our calipers and confirm that we have them sized to reflect the R to R interval, now let's measure and take a look at it. Lands halfway between that box, and the next beat occurs exactly where it should. And that's because the P to P interval is constant, the PR is constant, and the fact is that this QRS complex lands exactly where it should land. If you look at the ratio of P's to QRS's, it's going to be 4 to 3 or 3 to 2 or 7 to 6. It's always one more P wave than QRS complexes. So the easiest way to figure out what ratio it is look at the QRS's, and that's the second number. So the 2 QRS's, and therefore it must be 3 to 2 AV conduction with 1, 2, 3 P waves resulting in 2 QRS complexes. So pretty simple. Type 2 second degree AV block with a 3 to 2 pattern. But stay tuned for the next Chalk Talk because I'm going to show you something that looks a little bit different.